Hi, I'm Charlie Harp, the CEO of Clinical Architecture. I recently had a request to do a screencast on the new course subset for SNOMED CT. Started thinking about it and realized that I couldn't really do that without actually doing a little bit on SNOMED CT itself. So I'm going to try to give a quick overview of SNOMED CT and the new course subset, and I'm going to try to do it in about 15 minutes. All right, so first of all, who is this for? Well, this is really for somebody who knows what SNOMED CT is. They have basic database skills. So I'm going to be showing some data structures. They're interested in SNOMED CT, and they're not really familiar with it. So let's start off. What do you use SNOMED CT for? Well, SNOMED CT has a lot of stuff in it. What we're going to focus on right now is how we can use it to represent patient conditions, procedures, findings, things that you would have if you were trying to enhance your patient's electronic medical record in an EMR system. So when you start out looking at SNOMED CT, we're going to start with looking at the essentials. If you are a subscriber to SNOMED CT, you get a zip file. If you break that zip file open, what you find are a bunch of subfolders. Now, there's a lot of stuff in SNOMED CT. What we're going to focus on is the information that comes in the terminology content structures. There are basically three files that we care about. They're tab delimited text files, first row in the header, so they're very easy to import into Access. And those are going to be what we're going to focus on initially. And what they are the concepts, the descriptions, and the relationships in the SNOMED CT terminology. So we're looking at the concept, description, and relationship files. Basically, the files are text files. They have a year, month, and day associated with them. And like I said earlier, they have relationships, descriptions, and concepts. The concepts is really a file that is referenced by the relationship file and the descriptions file. And I'll talk more about that in a second. So let's start out by looking at the concepts file. File name is SCT_concepts_year, month, day .text. With the sample data I'm using, which is from way back in January, that's the file name. But this is basically what the file looks like. So what you have in the file is you have the concept ID, the concept status, which is one of those values down there. 0 means current, the fully specified name, the read code, the legacy SNOMED ID, and an is primitive indicator. Now, if we go through and look at this, the first thing I'm going to do is I'm going to get rid of the concept statuses that are not current. So I took the same data we were just looking at, and you might have noticed that there were some duplications. So here's heart disease excluded multiple times. 2 of these are not current. If you get rid of the ones that aren't current, what you end up with is a concise list that does not have a lot of duplication. Now, when I use the concepts file, I actually cheat a little bit. I get rid of the read codes, the SNOMED ID, and the is primitive because I just don't find them useful. The other thing I do is I only use current concepts, so I kind of get rid of that because it gives you a nice simple list of concept ID and identifiers. And then I do one more thing. I actually go through and I remove the types. One of the things I don't really understand about SNOMED CT, I think it's great that the terms have the types, but the fact that the fully specified name includes them in parentheses, I think kind of junks it up a little bit. So when I use it, I basically get rid of that. And I tend to bolt it on the side as an actual attribute of the term. As we get a little bit further along, you'll find out that these names are typically the preferred name in the descriptions table. So that, in a nutshell, is the concepts table. What's in SNOMED CT? So we have this table full of concepts. What's actually in there? Well, there's all kinds of types of concepts that live in that file. You can pause it here and look through the list. What I'm going to do next is I'm actually going to show you how it breaks down. If you take all the concept types that can live in the concept file and you break it down, what you get with the 386,965 terms, when you break them down, about 24% of those are disorders, 19% are procedures, 12% are findings, and the numbers go down from there. So you can pause here if you like and take a look. But that's just to give you an idea of what's in the total concept file. And this is current and inactive terms. So this is everything. Now, when you look at the descriptions table has the file name SCT-Descriptions, year, month, day.txt. So in our example, this is the one we're going to be looking at. When you open up the file, here's what it's got. It's got a description ID, which is a unique identifier for the description. The description status is the exact same as the concept status. It has the same value description pairs as the concept status. So I just use the same table for both. The concept ID is actually pointing to the concept that this is related to in the concept table. The term is the actual name as it's being represented, and we'll talk more about that in a second. The initial capital status is kind of a weird little field that basically tells you that regardless of where this gets inserted into a sentence, it tells you whether or not you should preserve the initial capitalization of the word, which is actually kind of handy if you think about it. So in this case, we've got morbus cordis, and basically what this is saying is keep the capital M on that, regardless of where it is in the sentence. The other thing you've got is a description type, and the description type has those values, the preferred term, a synonym, and a fully specified name. And you'll notice here for heart disease, which the concept I selected as heart disease, the one with the name in parentheses should have the same name that's in the concept table, and that's the fully specified name. And then the language code. Now, if you look at the language code in the description table, those are the three languages that actually exist. The documentation talks about Spanish, but the file I have doesn't have any Spanish in it. So the more current file might, but those are the three ones you look at, and by and large, a vast majority of them are just characterized as English. So if we look at the description table, basically what you've got is you've got a concept that is referenced by multiple descriptions in the description table, and the description has a type. And based upon the type, you can do different things with the description that you find. So in our example with heart failure, concept 8411407, heart failure parenthesis disorder, has a handful of descriptions. One is the fully specified name, one is the preferred term. Notice it does not have the type in parentheses, and then there are a handful of synonyms that can be useful for searching. One of the things that's interesting is this, in a way, is kind of like a little metathesaurus. So just like in the metathesaurus or in RX norm, you've got a SUI pointing back to a CUI, and all these terms pivot off of a conceptual term. That's kind of the way this works with concepts and descriptions in SNOMED. The descriptions are the terms, and the concept is the CUI. So just a little thing I thought I would add in there for those of you playing the home game. All right, so if you look at the relationships table is a little complicated just in the way that it works. So let's talk about it. There's the file name. There's the file we're going to be working with. When you look at the relationship file, you've got a relationship ID, you've got a concept ID, a relationship type, and a concept ID 2. All three of those things are concepts. Because remember, one of the types of concepts that we have in the concept file is relationship type. So this guy is leveraging the concept file quite a bit, and I'll show some actual relationships. The characteristic type tells you whether the relationship is a defining relationship, a qualifier, historical, or an additional characteristic relationship, and whether or not it's refinable, or whether or not it's mandatory that you refine the relationship. And the relationship group, which I have a whole slide to talk about, so we'll talk about the relationship group in a second. But once again, it's important to point out, ID can be null, all these things are concepts. The characteristic is telling you the type of relationship. Refinability tells you whether you need to refine it or not. And then the relationship group. The relationship group, according to the documentation, is a way to group relationships. But one of the things that's important is there's only 10 relationship group IDs when you do a distinct on relationship group. The thing that's important to remember is the relationship group is leveraged across multiple concepts. So for example, here you see relationship group of 1 across these concepts. All of these things aren't in a relationship group together. Rather, the unique combination of the concept and the relationship group creates that little nugget of relationship grouping. So in this case, these guys are grouped together under relationship group 1 for this concept. The fact that there's a maximum number of 10 for the relationship group means that there are concepts that are involved in up to 10 relationships. The other thing you can see here is you can see the base concept, you can see the relationship concept, the target, and whether or not it's refinable. Now, when you look at relationships in the relationship table, here's the breakdown. Obviously, a vast majority here, when you look at it, 82% of the relationships in the relationship table do not have a group, and only 18% do have a group. And a lot of the ones that have a group are similar to these, where they're basically defining elements of a procedure. Okay? So let's look a little bit more at relationships. A concept relates through a concept to another concept. And that's why I think it's just a little bit confusing, because it's a concept through a concept to a concept. And so when you look back at our friend heart disease, that sounds bad, what you see is that heart disease has this type of relationship to this guy and whether or not it's refinable. So here's one where you say heart disease, and this is a classification scheme. Heart disease is a disorder of the cardiovascular system. Heart disease is a cardiac finding. Heart disease has severities, and it's mandatory that you refine those if you're going to use it. Heart disease has episodicity, easy for me to say, which is mandatory, and it has a clinical course, which is mandatory. Heart disease has a finding site of the heart structure. So when you look through these relationships, they make perfect sense, and this is information that you can leverage when you're doing different things. I'm not going to get into the relationship stuff right now because that would take much, much longer than the 15 minutes I've tried to allot myself. So, this is one of those things you can read the documentation, you can dive into it. There's actually really good documentation in the documentation folder in the main zip file you get with Essentials. Okay? We did a very quick run through on SNOMED CT Essentials. What is the core subset? The core subset is a subset of SNOMED CT because SNOMED CT is huge. There's a lot of stuff in there. So what the good folks at NLM are doing, working with some institutions, is they are put together just a smaller set that people can start out with of terms out of the big superset of SNOMED CT concepts. So there's about 5,182 terms in the starter set. It came from Beth Israel Deaconess Medical Center, Intermountain Healthcare, Kaiser Permanente, Mayo Clinic, Nebraska University Medical Center, Regan Street Institute, and the Hong Kong Hospital Authority. When you look at this compared to what we saw earlier with the full concept types in SNOMED CT Essentials, obviously this one is weighted a little bit differently. Instead of being 24% disorder, this one is 73% disorder. It's mostly disorder, some findings, some procedure, a few of these other smaller things, but by and large, it's mostly a disorder subset. So how does this relate to SNOMED CT Essentials? So I've got this core subset, I've got Essentials. How do they relate to one another? Well, if you remember, when you looked at SNOMED CT Essentials, we've got a content folder with these 3 files in it down below. When you get the core subset, you basically get another zip file called SNOMED CT Core Subset with the year and the date. This zip file has 2 files in it, the core subset file and the release notes. The core subset file is basically a subset of the concept file in the Essentials data. So it doesn't have descriptions, it doesn't have relationships, it is just a subset of the concept file. So let's take a closer look. So there's the file name, there's the file we're going to be working with in this example. What you've got is the following file structure. You've got the SNOMED CID and the FSN. Those point to the concept ID and the fully specified name in the SCT_concepts table. Now this is one of those things where I'm curious why, when they created this, they went off with a different naming convention, because I think that makes it a little confusing. I really think that to preserve the learning curve of people that may have dove into SNOMED CT Essentials, that if it were me, I would call this column Concept ID, and I would call this column Fully Specified Name, just so that when people look at it, they make the cognitive leap to, oh, these are concepts coming out of the Essentials database. The other thing that I found curious is that they gave you the fully specified name, which I think if you're displaying that to a physician, they're going to say, why does it have the word disorder in parentheses? I also think that if it were me, I'd be pulling the preferred term in there. Maybe they were just assuming you would do that by joining it on the Essentials data, which we'll go through in a second. The concept status is the same concept status we talked about earlier. in the essentials data. The UMLS CUI is basically a link to the CUI column in the MR Conso RRF table from the UMLS Meta Thesaurus. The occurrence is how many out of the 7 institutions had this term in their list. So for example, you can see this one right here was only in one institution, whereas abdominal pain came out of all 7 of the institutions we named earlier. The usage number takes how often the term was used by each institution, totals it across the institutions that reported it, i.e. where there was an occurrence of the term, and then divides that total by 7, or the total number of institutions. This is interesting because the more occurrences a term has, the higher it's going to be rated, because the totals are representative of multiple institutions. I'd be curious to see what this number looked like if it was really the total of iterations of the term divided by the occurrence number,
and then is
representing the number of
everything is false right now.
They use the term.
And what they've said is this is for future use.
That would tell you really how often
the term
becomes
retired in the future
within the institutions that reported it.
Change. So
but this number actually
maybe
works
they
out
mean
really
it's retired from the core
and we'll
subset,
talk more
even
about
if the
that
concept status is
in a
still
minute.
active. I wasn't quite sure of what the purpose of that column was. One of the things I did with the core subset, because I wanted to play around with it, was I actually took the core subset data and I transformed it a little bit. I swapped out the fully specified name with the term from my essentials description data. I pulled everything else through and I ditched the is retired flag because it was always false. And if you want to learn how to do that, I mean, it's pretty straightforward. I'm working this in Access, so I've got the core subset in a table called core subset. I've got the descriptions in a table called description, and so I basically just wrote a query that looks like that grabbed the description where description type equals 1 and pulled that into the table. So you can pause that if you want to copy this down. That gave me a cleaner set. The other thing that's interesting is if you take the core subset data and you want to look at the occurrence and the usage data and the impact of that. If you look at the occurrence by percentage, a majority of the terms were presented by one institution. The second highest number is 2 and then 4, and then it goes 3, 5, 6, and 7. So the smallest number of terms were actually provided by all 7 institutions, and that probably makes sense. When I first saw the usage number, I was skeptical of how that was calculated. But when you look at the results of the usage number, and you look at the highest usage terms, here I grabbed the first, I don't know, what is maybe 25, that list kind of makes sense to me. So when I look at that, I mean, obviously these, since the occurrence is things that were included in multiple institutions, are going to be weighted higher. Most of the things in this list are 6 or 7. Well, child visit, even though it was only put together by 4 institutions, had a fairly high value. But when you look at this list, it seems like a reasonable list to me. And so when you look at it, it might seem like a reasonable list to you. I thought this was interesting, that they have the 2 spellings of anemia, but we'll leave that alone. So anyways, the thing to remember is the core subset's a starter set. If it were me, I wouldn't use the core subset as a feed into my system. I would use the core subset to select from the essentials data. You know, because the SNOMED CT data is really what I would be using, and that way, if something's not in the core subset, I can go to the CT essential concept data, search through the descriptions, and pull new terms into whatever my local data set is that I'm using. Use the core subset to select a subset from the essentials terminology, bring in the preferred term using description type equals 1, bring in synonyms not as their own terms, but bring them in as actual search terms, and that's kind of a design thing. When you design your search engine, you want to be able to bring those synonyms over so that people can find things, but for clinical decision support and to keep terminology creep to a minimum, I think storing the concepts in the patient file is probably a better idea. If you want to store the term that they use to search to get there, you can store that alongside it. But if you start driving any kind of clinical decision support, you're much better driving it off of a concept ID than a description ID. The other thing is the relationships can be interesting. So, become familiar with concepts and descriptions before tackling the relationships. Well, I think my time is up, so I want to say thank you very much. I hope this was interesting. Please, if we at Clinical Architecture can ever be of service, give us a call, stop by, clinicalarchitecture.com. I'm Charlie Harp. Thank you very much.